Hi, good morning, everyone. So last time we essentially looked at how the Egyptians came up with an area of a circle, and this is from one of the Egyptian papyrus scrolls, and we looked into their idea on how to compute the area, which is to take away the 1/9 of the diameter from the original diameter, taking the remainder and squaring it. Okay, and the result that they came up with was the number 64. Now, this topic is really about how did they come up with perhaps the number 1/9, and there are a few theories about it, and one of them is actually pretty cool that I wanted to talk about. Okay, so we essentially will take a look at a picture which will allow us to get a sense of how close were the Egyptians, right? How close was their formula, and how did they come up with it? When the Egyptians came up with the idea of 1/9 the diameter, you can essentially take this picture and get a rough sense of what they were trying to do. If you look at this entire piece, we have one big box, okay, and that has a circle inside of it, okay. And what the Egyptians said is that, if we divide this up into 9 compartments, okay, we know for a fact that if I were to draw this as a triangle, okay, so in this case, all the shaded areas, right? So if you were to take the shade area and let's label them, right? So this is shaded area, I'm going to just call them S, okay? Each of these shaded areas essentially are very, very close. They're essentially triangles. But if you were to take these shaded areas out of this big giant box, what we're left with is the area of the circle. Okay, so for example, if we were to take these shaded areas out, so let's just draw these out, and if we can take all of these out, if we were to take the entire box, you subtract these. So let's actually color these. So let's say this is the box and this is the color. Now we have these triangles, okay, and if we were to subtract each of these triangles from it, what we are going to be left with is sort of a figure like that. Which will be very close to the circle. Okay, so that was their thought process. All right, so let's sort of do some of the simple math here, right? So first thing you think about, what is the area of this box? The area of this box is very straightforward. We've got, this is 9 here, this is 9 here. So it's a square. So the area is simply a square of the length, which is 9 squared, okay, or 81. All right. So that was sort of easy to do. Now let's take these triangles, right? Let's take one of these triangles, okay? So let's take the bottom part of this triangle, which is this triangle right here, okay? So this triangle right here. Now, in this triangle, we know that this part here, okay, we know it's a right angle triangle. This part is 3, right? Because that's really what each of these lengths are. They are 3, okay? All right. And then we know this height is 3 as well, okay? All right. And we know that the area of a triangle is simply half times base times height, okay? But we have 4 of them, okay? So if we have 4 of them, what is the area of 4 of them? We just take this number and we multiply it by 4. So 4 of these triangles, okay, will have an area of 4 into half times 3. So this is sort of the area of one of these triangles, right? So if you were to do the math here, this is just 2 times 9, which is 18, okay? So this, in this case, would be number 18. And if you were to subtract both of them, what we are left with is 63, okay? 63, which is very, very close to the number 64 that the Egyptians came with. So here's an example that I thought was very, very cool, where, and I think this is sort of where the Egyptians kind of got their algorithm from, or their formula from, in terms of how to compute the area of a circle. Anyhow, I hope you guys enjoyed it, and we'll continue the session next time around.